In this video, we're going to take the formulas that we've learned for the sum of interior angles and the sum of exterior angles to use that with our regular and irregular polygons. So just a little review of the formulas. The sum of interior angles, is n minus 2 times 180. You want to memorize this. This isn't on a formula sheet, but it is super helpful. The interior angle is that first equation divided by the number of sides. And this only works for regular polygons. So that means only works when all of the angles and sides are equal. The sum of exterior angles, well, that's just 360. And the exterior angle of a regular polygon is 360 divided by n. Okay, so the sum, these two equations here, these work for any polygon, whether it is irregular or irregular. And then the second and fourth equation here, where you're dividing by n, those only work for regular polygons. If you're asked to find the number of sides of a polygon, you can just use that exterior angle and cross multiply, or you could memorize, and you don't have to memorize this one, but you could, that 360 divided by the exterior angle measure is equal to the number of sides. Okay, but you should definitely memorize these first four. For sure, memorize these. Okay, so let's practice a little bit here, and then we're going to talk about some irregular polygons, because up to this point I keep saying, oh, it only works for a regular polygon, and you should be thinking, well, what about those poor irregular polygons? What about them? We're gonna look at those in just a moment. All right, so what is the sum of the measures of the interior angles of a pentagon? All right, so you need to know that a pentagon has 5 sides, so n equals 5. Then you need to ask yourself, what equation am I going to use? Mrs. Granny just threw 5 of them at my face. What am I going to use? All right, well, we want the sum of the measures of the interior angles. So we want the sum of interior angles, that's that first equation, n minus 2 times 180. Okay, so this is the equation that we're going to use. And n is 5. So we're going to say 5 minus 2 times 180, or 3 times 180. So the sum of the interior angles of a pentagon is 540 degrees. On an assessment, that degree symbol will already be included for you. You do not need to type a degree symbol into any assessment. If the symbol is not on your standard keyboard, then I will not ask you to type that into an assessment. Okay, so if you're trying to be very diligent about including your units, that is great. Just know that I'm not going to be asking you to include that degree symbol, and the answer key on the assessments won't be including the degree symbol. So any assessment, the units will already be included for you. All right, let's practice this again. Go ahead and try number 2. What's the sum of the measures of the interior angles of a 27-gon? Try this one now. All right, you should have gotten 4,500 degrees. Ooh, I'm glad I don't have to sit there with a protractor, measure every angle and add it together. That would take a while. I'm glad we have this formula to be able to figure that out. Number 3, we're going to find the measure of each interior angle of a regular octagon. Regular meaning that all the sides and all the angles are equal measures. Okay, so the measure for a regular polygon and interior angle. Let's look at our formula. The interior angle of a regular polygon, it's that second equation. So we're going to use that n minus 2 times 180 divided by n. So the sum of all of the angles divided by however many angles there are. So n in this case is 8 because it's an octagon. Octagons have 8 sides. All right, well, 8 minus 2 is 6. 6 times 180 is 1,080, and then divide that by 8. And you could just type this whole thing straight into Desmos, and it will give you 135 degrees. So every angle in a regular octagon or every interior angle of a regular octagon is 135 degrees. All right, go ahead and try number 4. What's the measure of each interior angle of a regular 20gon? Try this one now. All right, so you should get 162 degrees. This works because it is a regular 20gon, which means all 20 angles in that polygon are all the same measure. All right, cool. Now number 5 gets interesting. Number 5 says 5 angles of a hexagon are these 5 numbers. What's the measure of that 6th angle? So picture a hexagon that is not a regular hexagon. And I know it's not regular because these angles they give us are not all the same. So I'm going to call that 6th angle x. Okay, well, we know an equation for the sum of interior angles. The sum of interior angles is n minus 2 times 180. And this equation works for all polygons, not just regular ones, but all of them. So the sum of the interior angles of a hexagon will be 6 minus 2 times 180, which is 4 times 180, so 720. Okay. Now, what does sum mean? Well, sum means add together. So I could add all of the angles together, and that would be the sum of the angles, that 6th one being x. So I could add all the angles together. That is the sum. That is the sum of all the angles. Wait a second. These mean the same thing. The sum of the interior angles, and this is the sum of the interior angles. 2 ways to represent the same thing, which means they must be equal. So I can say that this equals 720. Whether I use the equation to find the sum of interior angles or I actually add those angles together, I'm finding the same thing. So now what I can do is I can just solve for x in this equation. Combine all those like terms, add the 119, 129, 104, 139, 95. When I do that, I get 586. So this becomes 586 plus x equals 720. Subtract 586 from both sides, 134. So that last missing angle is a 134 degree angle. So this is how we can use that sum of interior angles equation when our polygon is not a regular polygon. Okay. Let's do it one more time. This one's a little different though, because it's saying how many sides does this thing have? All right. The sum of the interior angles of a polygon is 1,620. How many sides does it have? All right, well, sum of interior angles. We know that the equation for the sum of interior angles is this. N minus 2 times 180. And it says that the sum of interior angles is 1,620. How many sides does it have? What's n equal, right? How many sides? All right, so what we're going to do here is we're going to solve for n. So I'm going to set this up slightly different, right? We talked about this a little bit on the last couple slides ago, maybe even in the last video too, that multiplication is commutative. So I can flip-flop these and it means the same thing. And when I do that, I can see my distributive property come into play. There's another way to solve this, and I'll show you in a minute. I like the distributive property. And I'm going to use that now so I can solve for n. I'm going to add 360 to both sides. One 620 plus 360, 1980, and then I'm going to divide both sides by 180. I get 11. So this is an 11-gon. If you want to know, an 11-gon is also called a hendecagon. It's kind of fun to say. Okay, there's another way to do it. If you would set it up, okay, well, the sum of interior angles is 1620. What you could have done here is divide both sides by 180. That would have been okay. That would have made these 180s cancel. And 1620 divided by 180 is 9. And then add 2 to both sides. Either way, they are both right. Whichever algebra method you prefer, neither one of them is wrong. You want to use distribution? Cool, use distribution. You want to divide by 180 first? Cool, that's okay too. Both ways are algebraically solid and will work. And it doesn't matter to me which way you use as long as you get it right. There is a third option. I don't like to point this one out because I feel like it's cheating. Most of the time, I'm going to say 99% of the time, questions like this will be multiple choice. If they're multiple choice, you could literally take each of your options, plug them in for n, and see which one gets you the 1620. I don't like that option. I feel like it's cheating. You definitely need to know how to solve this algebra as you're moving on into further math classes. But if you got this type of problem in a multiple choice, you could take your 4 options, plug each one in for n, and see which one gets you that sum of exterior angles that you're looking for. All right, number 7. Number 7 is just like the problem we just did. The only thing that's different is the sum of those interior angles is a different number. Can you figure out how many sides this polygon has? This one's not multiple choice, so you're going to have to use algebra to solve it. But you can do it. You can look back at the last example that I just did here, and you can choose if you want to use distribution or if you want to divide by 180 first. The setup will be the same for either option that you choose. And then solve for n. How many sides does our polygon have here, whose sum of interior angles is 3,960? Try number 7 now. You should have gotten 24 sides on this polygon. Would it make sense to get the number of sides with a decimal? Would it make sense to say 5.5 or 10.2? Would that make sense? No, it wouldn't make sense. Number of sides has to be a whole number. It either has 3 sides or 4 sides. I can't have a polygon with 3.5 sides, right? I can't have half of a side. It's still a side. That's like saying I dug half of a hole. Well, as soon as I started digging, that's a hole. So I can't have a decimal or a fraction number when I'm talking about number of sides. Usually I say, hey, fractions are friends. Don't be afraid of fractions. And that's true. But when we're talking about number of things, we have to have whole numbers. So we have to have a whole number of sides. It also wouldn't make sense to get negative numbers. So if you got a negative number of sides, you know you did some algebra wrong somewhere. So your number of sides, of course, has to be positive. It has to be a whole number. And it certainly has to be bigger than 3, right? Because I can't have a polygon with just 2 sides. All right, cool. Let's look at number 8. What is the sum of the measures of the exterior angles of a nonagon? Nonagon has 9 sides. The sum of the measures of exterior angles. Oh wait, I don't even care how many sides there has, because we know the sum of the measures of the exterior angles of any polygon is 360. I will tell you, this is the most missed problem on all of my tests. In my 11 years of teaching, this is probably the most missed problem because I think it's probably the easiest one. There's no formula to figure out. There's no formula to plug an n into. You just need to know that the measure of those exterior angles is 360 degrees. That's it. So maybe it being too easy makes it too hard. I don't know. But please study that the number, right? That the exterior angles of a polygon, any polygon in the world, the sum of those exterior angles will always sum to 360. Now, number 9, what is the measure of each exterior angle of a regular 20gon? That's where you're going to say, oh, well, the total number of angles on the exterior, the total degrees of those exterior angles divided by however many angles there are. And this works because it's a regular polygon. So 360 divided by 20 tells me that this is an 18gon. It has, or sorry, not 18gon, it has 18 degrees. Each exterior angle of this 20gon is 18 degrees. Okay. Cool. So that was just a little review of how to use those exterior angles theorems. Here's some more practice on how to find missing number of sides. And then we got some irregular polygons again. Yay for those. All right, number 10, if the exterior angle of a regular polygon, all right, so all of these angles are the same measure. The exterior angle of a regular polygon is 9. How many sides does it have? Okay, so we're missing n. I know that the sum of the exterior angles, all of the exterior angles added together is 360. I don't know how many there are, but I know they're all the same size. And when I divide by however many there are, I'm going to get 9. So now I can cross multiply. And if you want to use that other equation, you are welcome to do that. We're going to end up doing that anyway here in 1 second when I divide both sides by 9. Right? Cross multiply, I got 360. 9 times n is 9n, and then divide both sides by 9. 360 divided by 9 is 40. This is a 40gon. That's 40 sides. If the interior angle of a regular polygon measures 108, how many sides does it have? So interior angle, and this is one of them. So one interior angle of a regular polygon is represented by this formula, which we'll have memorized by the time the quiz and the test comes. Each one is 108 degrees. So now I'm going to cross multiply. I don't know n. N is what I'm solving for. So let's cross multiply. N minus 2 times 180 times 1, it's just n minus 2 times 180. N times 108 is 108n. Now this one is one where you will need to distribute. There's not a little slick shortcut. You're going to have to distribute. So you can rewrite this as 180 times n minus 2 if that makes you feel better. If you're okay with distributing from the right side, that's okay too. I'm going to subtract 108n from both sides. It's going to feel a little uncomfortable for a moment because I'm going to get 72n minus 360 equals 0. But then I'm going to add 360 to both sides. So now I have 72n equals 360. And I can divide both sides by 72. So this is a pentagon. It has 5 sides. I'd like to show you how you can solve this using Desmos. I think some students really like using the Desmos to solve, and it can make this go quicker. So I'd like to show you how to use Desmos to solve this equation. Okay, on my screen, you can see the Desmos calculator, and this is the testing calculator. There is a different way to do it in the regular Desmos calculator, but if you're taking an SOL, you won't have that regular Desmos calculator. So I'm showing you on the testing calculator so that we have all of our bases covered. All right, so what I have here is I have the left side of the equation entered. So I have a y equals, and I put the left side of the equation. That was the n minus 2 times 180. Now the thing is, it doesn't like it when you use a variable that's not x. So I just, instead of putting n, I put an x, because that's what I'm trying to solve for. Then the second equation is the right side of what I had. So y equals, and the right side was 108n. So in this case, it's 108x, so that I can solve for x. Do be very careful. I always type 108 wrong because we use 180 so much in this class that when that number 108 comes up, I always flub it. So just be very careful that you are typing those numbers incorrectly. Now, our goal is to see where do my red and my green lines intersect. And sometimes that is a pain, especially, right? See, they're going to intersect. They have to intersect. It's just, oh my, scrolling's kind of annoying. So you can play with the settings on that graph. You know that n has to be positive. So n in this case is x, right, while I'm graphing. So I don't need anything negative. Let's make it go up to 40 for right now. You know that it's going to intersect in the positive y part, so I don't need anything there. And then, I don't know, pick a number. Clearly, it's high up there, right? I kept scrolling and scrolling, and I still didn't get to it. So let's make it like 600. Look, there's the intersection. Okay, so the goal here is to find the intersection. Whether you scroll or you mess with the axes, you need to find that intersection. And when you click on that intersection, there it is. See my x value? My x value is 5. And in my equation, this x was really n. So n is 5. So that's how you could use Desmos to solve this. Clearly, it's not as easy as some of the other ways we've used Desmos to solve an equation because our numbers were so big, but it is possible. So if you like using the Desmos, there you go. Just note that you may have to adjust your settings over here, your x-axis and your y-axis, to make it easier to find. Okay, we're never going to have a negative number for signs, and we're never going to have negative degrees. So you can always make it bigger than 0, and then you can play with these numbers to just kind of guess and check until you find your intersection, or you can at least get it to where you can scroll to find that intersection. Hopefully you found that helpful. Personally, I like to use the formulas and just solve it by hand using algebra. But whichever way works for you, as long as you get that answer, I'm happy with that. And again, if they give you a multiple choice question like this, you could always just plug those numbers in for n and see which one makes it work. Okay, let's look at number 12. Number 12, we have an irregular polygon. Okay, we have an irregular quadrilateral. It has 4 sides, it has 4 angles, but they are not all equal. So we are going to use that sum of interior angles to our advantage. So sum of interior angles is n minus 2 times 180. Well, n in this case is 4. 4 minus 2 is 2. 2 times 180 is 360. So the sum of interior angles is 360. Sum means that you add them together. So I can say, oh, this plus this plus this plus this, they all have to add up to the sum of interior angles, or 360. So we can say 79 plus 110 plus 55 plus that missing angle, 55. They all have to add up to 360. So that's going to be 360. And now we can just solve for x. Combine our like terms, 79 and 110 and 55, add those together. So when I combine those like terms, I get 244. So this becomes 244 plus x equals 360. And now I can subtract 244 from both sides. 116. All right, so x equals 116 degrees. I try really, really hard to make sure that any problem that you are given on a notes, on a practice, on an assessment is drawn to scale. So when I look at this picture and I see this angle, that is an obtuse angle. So my answer had better be bigger than 90, and it is. There are some problems I have seen that exist out there in the world where they don't necessarily draw them to scale, or they draw them in a way that it makes it hard to just guess. There's no guessing here. You should be using the formula for the sum of interior angles. You should be adding those interior angles together and making those things equal. A lot of times students will stop me right here and they will say, whoa, 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 Mrs. Grandy, pause a second. Where'd you get that 360 from? So let me just talk about that one more time. Okay, this 360 came from using the equations from the sum of interior angles. That sum of interior angles is n minus 2 times 180. So when I plug in n is 4. 4 minus 2 times 180 is 360. That's where this number came from. This number will be different for different polygons, right? It's not going to be 360 for a pentagon. It's not going to be 360 for a decagon. It's only 360 for a quadrilateral. So to figure out what number I'm plugging in here, I have to use the sum of interior angles formula, plug it in to that sum when I'm adding them together. Okay, I'd like you to try number 13. Try it out, and then I will go over it. Okay, So use that sum of interior angles equation, figure out what should all these angles add up together to be, then actually add them together and figure out what that missing angle is. Try this one now. Did you get that missing angle x is 94 degrees? If you did, great job. If not, let's see if we can find your mistake. Okay, so I just want to talk about the process that I used to solve for x. All right, so we know that this has 7 sides. How do we know that? Well, you can count the sides. Sometimes those sides are kind of wonky looking. So if you're not sure, count the angles. Angles and sides, so they're going to have the same number. So however many sides a polygon has is the number of angles it has. So when we count how many angles there are, there's 7. So n is 7. And we can use the equation for the sum of interior angles to find what do all 7 of those angles have to add up to. The sum of interior angles is n minus 2 times 180, 900. So I know that whatever these numbers are, they have to add to 900. Remember, this little box means 90. Okay, so this is 90 plus 140 plus 148 plus 140 plus 136 plus x plus 142 plus 150. The sum of those, adding those all together, has to equal 900. And I know that 900 because I get that from the equation for sum of interior angles. Combine those like terms. Just add them together. Use Desmos. Add those like terms together. You get 806. So now you have 806 plus x equals 900. Subtract 806 from both sides, and that's where the 94 comes from. So this kind of looks like a 90-degree angle, right? It's only 4 degrees bigger than that. So definitely you can't look at it and just guess, because you can't just say, oh, it's 90, that looks right. No. Use the numbers, use the equations to make sure that you got that. Okay, and if you really wanted to use Desmos to solve this, you could. Right? You would just have to be either scrolling around on the graph to find where they intersect, or adjust your x-axis and y-axis numbers to be able to find it. All right, now we get more irregular polygons, but this time we're going to play with algebra just a little bit more, because instead of just numbers, we have expressions. It's the same idea though. We're going to find n. We're going to find the sum of the interior angles. What should these all add up to? Then we're actually going to add them together and be able to solve for x. So let's start with that. First, we need to know n. Okay, so how many sides does it have, or how many angles does it have? 1, 2, 3, 4, 5, 6, 6. This is a hexagon. This is an irregular hexagon. So what should these angles all add up to? N minus 2 times 180 will tell me what the sum of those interior angles are. That's 6 minus 2 times 180. 6 minus 2 is 4. 4 times 180 is 720. So these angles, they all have to add up to 720. So let's do it. Let's add them all together. We're going to add all 6 of these angles together and get 720. So I'm going to start with that 110. 110 plus 8x minus 1 plus 5x plus 36 plus 116 plus 7x plus 19 plus 6x minus 2. There they are. There's all 6 angles. They all have to add up to the sum of interior angles, 720. So I'm going to put that right there. All right, now we play algebra. I'm going to combine my like terms. It got kind of long here, so just use caution when you're combining your like terms. 8x, 5x, 7x, and 6x. We get 26x. Now let's combine all of the non-x terms. I'll use Polygons. So 110 minus 1 plus 36 plus 116 plus 19 minus 2. And I'm using a calculator. I'm not doing this mental math, and I don't expect you to do mental math like that either. 278. Okay, I haven't actually solved anything. I've just combined like terms. So this still equals 720. Now we'll subtract 278 from both sides. 720 minus 278, we get 442. And then divide both sides by 26, and we get 17. So x equals 17. It was just asking us to solve for x, so we can stop right there. If it was asking us to find the measure of one of these angles, we could use substitution and substitute that x for any of these angles to find their actual measures. Oh, look, number 15. Number 15 wants us to find the measure of angle B. So we're going to do the same process we just did here in 14, but then we're going to take whatever x equals and we're going to plug it into that expression there for B. Okay, this one isn't a hexagon, it's just a quadrilateral, so it won't be as long. It is the same process though, so go ahead and try number 15. Can you find the value of x? And then once you know x, tell me what the measure of angle B is. Try this one now. All right, you should have gotten x equals 9. When you plug 9 in for angle B, you should have gotten that angle B equals 79 degrees. Now, if you set up your equation and you added the expressions in a different order than I did, like I started with 8x plus 7, but if you started with one of the other angles, that's okay. Addition's commutative. It doesn't matter which order you add in. So if you started with one of these other angles to start with, that's okay. You know you did it right if when you combined your like terms, you still got 37x plus 27. Okay. So if you set this up in a different order than I did, not a big deal, because when you combine your like terms, we still get the same thing. If you didn't get this, or if you didn't get 9 and 79, check your work, check to make sure that you got that 360. Check to make sure that you remembered to add all 4 expressions. Make sure you combine those like terms correctly. Make sure you subtracted correctly. I do that all the time. When I'm subtracting, I accidentally add. So double check that, make sure you got that 333, and make sure you divided correctly. If you can't find your mistake, you are welcome to take a picture of it or a screenshot or however you're doing your work and send it to me, and I can look at it and see if I can find any errors. And you're welcome to do that with any problem, not just this one. If you're ever working on a problem and you can't find your error, you know there's an error, but you can't find it, send me a picture of it. Whether you take a picture of it with your phone or you're doing it on a screen and you want to send me a screenshot, or you want to send me what you're putting into Desmos, I'm always happy to look at your work and help you out. All right, these two look fun. Just solve for x. Now, number 16 only gives me the measure of one angle. That's interesting. Well, see all those tick marks? These tick marks mean that all the sides are the same, which means this is a regular polygon. How many sides does it have? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, n equals 10. There's 10 sides here. They're all the same length, which means all the angles are the same. Cool. All right. Well, one interior angle of a decagon. Let's find it. We know the equation for one interior angle of a regular polygon. An interior angle of a regular polygon is n minus 2 times 180 divided by n, which we're going to have memorized by the time the quiz and the test comes. In this case, n is 10. So let's find the measure of one interior angle. 10 minus 2 times 180, all divided by 10. Okay, well, 10 minus 2 is 8. 8 times 180, divide that by 10. Each angle here measures 144 degrees. So that means all of these interior angles, every single one of them is 144. I don't know expressions for all of them, but I know an expression for this one. So this one also has to be 144. And now we have an equation to solve. Subtract 4 from both sides. Divide by 10. There it is. So if it gives you the measure of one interior angle of a regular polygon, you can use that equation for one interior angle of a regular polygon to help you solve. All right, number 17, let's solve for x. In this picture, they're giving me all exterior angles. All these angles are all on the outside. Okay. Well, we know that the sum of the exterior angles is always 360. Sum of exterior angles is always 360. Always, always. So why don't we go ahead and add all of the exterior angles together? That's the sum of the exterior angles when we're actually just adding them. I wrote too big. There we go. So the sum of those exterior angles is when I add the exterior angles together. We know that they have to sum to 360. So I'm going to say that they all have to equal 360. And now we just play algebra. Combine our like terms. Let's see, 5x, 4x, 9x, 4x, and 7x. Add those together, we get 29x. If you don't believe me, go ahead and grab a calculator and check it. And now we'll combine all of our non-x values. 4, 9, -6, 1, 4. That's 12. I haven't actually solved anything, just combined my like terms, so this still equals 360. This equation's a lot nicer to look at though. We'll subtract 12 from both sides. 360 minus 12, 348. Divide both sides by 29. If you need to pause the video and make sure that you can do that yourself, you're welcome to do that. I know I came up with those numbers pretty quickly, but if you want to try and make sure that you get those numbers yourself, you're welcome to pause the video and make sure that you can definitely get that 29x and that 12. But we get x equals 12 for this one. We know that the sum of the exterior angles is indeed 360. So if we just add those exterior angles together, they have to add up to 360 degrees. All right, so this video was just a review of how to use all of the formulas that we've done so far. Sum of interior angles, one interior angle of a regular polygon, sum of exterior angles, one exterior angle of a polygon, and using those formulas to also help us when we have irregular polygons. All right, have a great day.